improving insight into variables that influence health and return to work outcomes of a claiming population. RMIT Data Science Postgraduate Project Final Presentation.
Hi, I'm Thimira.
I'm Samalka, and we were assigned to the capstone project of MedHealth Private Limited, and the content of this presentation are as follows.
Introduction to the project partner and scope.
Methodology,
Results obtained.
challenges we faced,
Future of the project and conclusion.
Who is MedHealth? MedHealth is part of a global network called ExamWorks, and that includes Australia, USA, and UK. So it's a group of companies that provide specialized guidance and medical assessment to their clients, such as insurance and government agencies, which assist in financial, health and employment support for injured or ill people. Their slogan speaks for themselves, which says, and I quote, "We help organizations improve health and employment outcomes of a population while never losing sight of an individual." The following picture shows MedHealth's role in providing assistance. We will take a look at this in detail in the next slide. Before moving to the actual project, let's take a look at some of the definitions that may be helpful in understanding the project better. Like mentioned earlier, MedHealth assists by providing medical reports. These are commonly known as IMEs or Independent Medical Examination Reports, and they are done by a medical consultant at MedHealth. These reports are necessary if you are claiming benefits under compulsory third-party insurance known as CTP or workers' compensation. CTP is for claimants who are involved in a vehicle accident, and workers' comp is for claimants injured at work. A typical IME report also consists of a numerical percentage value, most commonly known as WPI or whole person's impairment, which is the assessment of degree of injury, and this could be physical or psychiatric as well. Figure number 1 shows how a claim can be made by either an individual under CTP and by employer under workers' comp, and how these claims are forwarded to MedHealth for assessment through an agent. Also note that different states have different protocols on how the entire process is handled in Australia.
The project with MedHealth was more about finding something actionable out of data provided for us. The project aims were therefore just a guideline, and this included uncovering variables that may affect claim outcomes, exploring more ways to enrich the data, patient profiling, which included patient data from IME report, which is phase 1, case profiling, which included additional details belonging to claim, which is phase 2 of the project. Project outcomes included a developed dashboard for phase 1 and phase 2 and suggestions for the future of the project. Methodology. We use tools such as Power BI for developing dashboards, Python for scripting, and Excel for quick analysis. The data we use came from the IME reports for 2020 of different clients of MedHealth. Python script was used to extract the free text data from the reports to a CSV format. This included the top part of the IME report, and these variables were unstructured data. We also managed to get company structured data that we later combined with unstructured data to come up with consolidated data set. Structured data included report key, which is unique for every IME, specialty, which can be orthopedic, psychiatric, or other specialties, gender could be male, female, or other, and so on. Unstructured data included occupation, age, employer of claimant, diagnosis of the claimant, any pre-existing condition, and so on.
Data extraction. The following shows a glimpse of our Python script structure we use for extracting data from free text format to 12 different CSV files according to the 12 months of 2020. First, import libraries such as pandas, docx, and regex. Make a list for 12 months, Jan, Feb, March, like so. Then give the report paths. Then we created a function to get the top data from the reports. This includes all paragraphs from the top part of the IME report. A loop to define the variables such as occupation, injury date, and so on. A nested for loop inside the loop I mentioned earlier with an if-else condition to break the right part of variables. Connect the variables to be written to a CSV format and give the output path with UTF-8 encoding. So that's how we simply extracted the data.
Data preprocessing. Structured data was in an easy format. Unstructured data was preprocessed in Python, which included typical steps like splitting by delimiters, transforming to uppercases, and removing punctuation marks. Power queries were also used to preprocess some variable when visualizing.
Let's take a look at some of the questions that we were trying to answer using data visualization techniques such as bar plots, histograms, density plots, and so on. We wanted to see the age distribution of claimants depending on different schemes, which can be CTP, workers' comp, or subcategories under that. We also wanted to see the distribution of claims for one particular client of MedHealth, and also to see the WPI percentage variation across the narrowed down client specialty group. We also wanted to see what insights can be obtained from various variables such as occupation. Is there a particular occupation sector that has higher WPI percentage values than others or not? So those were some of the questions that we were interested to dig into.
Phase 1 of the project, which was on patient profiling. This included the data belonging to the top part of the IME, that is, de-identified patient demographics and doctor data. Power BI dashboards were used here, and we also use Python for NLP techniques like vectorizing, stop word removal, stemming, lemmatization, tokenizing, and text clustering using TF-IDF method for occupation variable. While we were trying out clustering, we were given Australian and New Zealand standard classification of occupation to group the occupation. Later on, we went on with it.
Here let's see the steps for frequency table and processing the occupation column, which we call job type here for text clustering. Typical Python libraries such as Matplotlib, Pandas, and sklearn for modeling, and more importantly, the NLTK library for natural language processing was used here. Before actually doing any text clustering, we made a frequency table with the most repetitive occupations to get a basic understanding of the occupation column. The script for that followed a structure as follows. So importing the libraries, then pre-processing the variable by splitting by delimiter, removing punctuation, and other typical other ranking steps. Then we created the counter vectorized method for transforming the text into a vector using unigrams and bigrams. Then we fitted this count vector to job type column, creating a matrix and then summarizing it to an array. Getting the frequency of the uni and bigrams by creating a data frame and saving it as a CSV where output was a frequency table with different jobs. Before fitting a cluster model, the following scripting steps were then done in the given order. First, we removed the stop words that don't alter the meaning, such as the, is, are, have from the job type column. Then we transformed them all to lowercase. Then we tokenized by splitting phrases into units of words. Then we created stemmed words that removed the suffix of the words. And finally, we use lemmatization technique for keeping only the base meaning of the word. And that's how we processed the data for clustering.
Here is how we approach text clustering using Python scripting. First, transform the text data that we processed, which we discussed in the previous slide, to feature vectors that can be used as an input to the estimator. So we use DFIDF method for calculating importance, then finding the optimal number of clusters using k-means, which is unsupervised learning. Then use sum of squared method to plot a graph to find a turning point indication, the optimal clusters, and using that to fit the model, getting the most representative word in each cluster group as output. So this gave us satisfactory result, which we'll see later in the presentation. However, we did not perfected it further due to receiving a predefined criteria for job classification named as NSCO.
Phase 2 of the project was on case profiling, and the data used for this was from the middle and the end portion of the IME report. This included the medical history and also the questions and answers given by the medical consultant and the claimant. For this part, we had to manually go through a certain number of de-identified reports belonging to a specific client sector to double check whether the extracted whole person impairment percentage was accurate or not, which was not the ideal way to do in terms of data science, but given the circumstances, that was what had to be done in order to get the WPI percentage. We also managed to extract whether claimants have a X situation or not. This was one of the important factors in the project as well. We managed to scan through a certain number of de-identified reports to find the most common questions, and we used Power BI dashboards to communicate our findings to our supervisors. Results of our project. Due to the time limit, in this presentation we'll be only looking at some of the results we obtained, and this is by no means the entire result set. Results for phase 1. The following figure 3 shows the dashboard page for age variable respective to different scheme groups. The schemes are A, B, C or D in this case. We found that group A follows almost a normal distribution, with claimants being a mix of young and old. Group B was slightly left skewed between 20 to 45 years. Group C, on the other hand, was towards the right, with older claimants being more common in that group. The most distinct insight we obtained was for Group D, where the distribution was left skewed, with more claimants being younger than normal, which is 20 to 35 years, which made sense to our supervisors according to their domain knowledge, as the group included claimants mostly from Army, Navy or other defense forces, so it was deemed natural to be impaired at a young age.
Here, let's take a look at the occupation clustering results. Figure 4 shows a part of the frequency table we obtained before committing to text clusters, with the highest count being for veterans. Figure 5 shows a number of clusters that could potentially work for the occupation variable. Looking at the change point at 10, we choose to use 10 clusters at first. Figure 6 shows the clusters we got with the topmost repeated words in each cluster. They gave considerably similar words within a cluster. So we stopped analyzing other clustering methods since we later got the Australian and New Zealand standard classification of occupation to group the occupations. However, the script was deemed useful for other variables as well and may be used in the next project.
Results of phase 2. Figure 7 here shows the dashboard page for client sector 2 in specialty 2. Specialty 2 in this case could be one of the specialties we mentioned in the data section, that is orthopedic, psychiatric and so on. We managed to extract WPI percentage values from de-identified reports with an extraction rate of 86% in this case. We also saw that majority of cases were from one particular state, which was about 84% of the total cases. This information gave a rise to a question which is why are the majority cases from this particular state and why are they not receiving from the other states. So which is a question that should be dealt with the management. We also found out that a certain percentage of the cases showed an X situation that we mentioned earlier also that will influence the claim outcome. Average WPI percentage for all genders were almost equal. So that was also one of the key findings. We also managed to calculate the percentage values that indicated mild or moderately impaired cases. And according to the impairment criteria given, there were no cases that were marked or severely impaired. The importance of these impairment findings was that either the WPI percentage for specialty 2, for client 2, were all either no impairment, mild or moderate. This could either mean that MedHealth is not receiving severe claims or that specialty 2 in general is lower than other specialties. So with this information, MedHealth team told that they'll be looking into the reasons behind this. So that was one key finding. We managed to screen through most common questions that were present in the reports. We, however, cannot present them all here. But out of them, the question, is there a certain, let's say, X situation present or not, seemed to be one of the most important at this stage. Going back to our previous results, we managed to see that a certain percentage of cases had this said X situation associated with it, which actually can directly impact the outcome of a claim benefit. So this was one key finding from our research here. In white color, we have the results of average WPI percentages for occupation classification using the Australian and New Zealand standard classification of occupations. Occupation sector 1 here had the lowest average whole person impairment, which is 2.92 as you see, and this sector actually consisted of professional occupations such as teachers, managers, directors and accountants, which means that in general the degree of impairment or the damage is lower for claimants who work on a professional setting rather than any other occupation sector, let's say labor or machinery.
Future recommendation. The project does not end here. With the use of analysis, the project can evolve to the next phase with the more data as the foundation is laid here. MedHealth can use the same occupation criteria to compare with other client sectors. They can also analyze other major client specialties as well with the same scripts. One major recommendation we have for MedHealth is to do with collecting data in a way that is efficient for analysis, which can be done at the root where the initial data is collected, that is by the medical consultants. A simple template with yes or no question could be provided to medical consultant in addition to the normal IME report specification. That way, extracting binary answers are easier than analyzing paragraphs.
Challenges faced. The challenges we expected to face were related to machine learning models or coming up with algorithms, but in reality, the most difficult challenge was understanding the business structure. What it's exactly that MedHealth do.
We realize how important the domain expertise in data science as well.
Corporate procedure can be time consuming and not so straightforward as we think. In fact, it took us 4 weeks to solve IT and work laptop issues.
Accuracy of something doesn't mean anything if the context is not valid.
Sometimes all you need is a simple bar plot to understand the data.
Conclusion. Data were extracted initially from the free text to CSV format using Python.
Improving insight into variables that influence health and return to work outcomes of a claiming population was successfully achieved with analyzing different variables in both phase 1 and phase 2 of the project.
NLP techniques were used in text clustering of occupation variable. Phase 1 gave insights to patient data distribution among schemas, and Phase 2 gave insights to case data while overlapping with Phase 1. Common questions in IME report were identified.
Then Power BI dashboards was used as communication tools to present our data.
Overall, our experience with the MedHealth team was positive, and we gained confidence with ourselves along the project, and we are satisfied with the outcome of the project.
Finally, we would make this an opportunity to thank the MedHealth team and RMIT for the support and guidance throughout the project.
Thank you.